Good afternoon, everybody. Today we are going to try to sketch the graph of an exponential function and explicitly state all of its transformations off of the parent function. We should state we're going to use the parent function y is equal to 2 to the x. Y is equal to 2 to the x. Okay, so our base is 2. We have a vertical stretch of 3. The negative at the very front means we have a reflection about the x-axis. That exponent, we're going to need to rewrite this in real transformational form. And so that negative needs to be factored out of both terms. And so I'm going to rewrite this equation as y is equal to negative 3 times 2 to the negative bracket x plus 1, which is its real transformational form. And again, the plus 2 at the end. So written in this form, we see that we have a horizontal translation of, with the x plus 1, horizontal translation of negative 1. The negative in the exponent means an ry, a reflection about the y-axis, an ry. And finally, the plus 2 at the very end means a vertical translation of positive 2. So now that means that we know that our horizontal asymptote, as is common to all exponential functions, is the line y is equal to our vertical translation, y is equal to 2. And so we have a horizontal asymptote like so at y is equal to 2. This is going to be a reflection in the y and x-axis. So instead of the typical graph that looks like this, it's going to be and reflected both ways. So we could start by getting the y-intercept. We get the y-intercept, which means setting x equal to 0, and then y would be negative 3 times 2 to the power of negative 0 minus 1 plus 2, which is negative 3 times 2 to the negative 1 plus 2, which is negative 3 over 2. I will remind you that 2 to the negative 1 means 1 over 2, and so 3 times 1 over 2 is 3 over 2. Plus 2, and negative 3 over 2 plus 2 is positive 0.5. And so that means that we have a y-intercept at y is equal to 0.5, around there. Okay. To get the x-intercept, if you have not studied logarithms yet, you won't be able to algebraically find this, but for what it's worth, we'll do it in this video. So we're going to set y is equal to 0, meaning 0 is equal to negative 3 times 2 to the power of negative x minus 1 plus 2. Now, to solve this, we are going to subtract 2 from both sides. So negative 2 is equal to negative 3 times 2 to the power of negative x minus 1. Then we'll divide both sides by negative 3, meaning that 2 over 3 is equal to 2 to the power of negative x minus 1. And now what we do is we take the logarithm base 2 of both sides. And so we're going to have the log base 2, since there's a 2 there, of 2/3 is going to be equal to the exponent negative x minus 1. And on a calculator, I'll give you guys an easier strategy. Log base 2 of 2/3, your log button on a calculator is log base 10. That's the default log base. And so we can write this as, it's one of your logarithmic rules. You can look them up online. We can write this as the log base 10, which is what the log button on your calculator is likely to be, of 2/3 divided by the log base 10 of 2. That's what this value can be computed as. And that's equal to negative x minus 1. Which means that negative x is equal to log base 10 of 2/3 divided by log base 10 of 2 plus 1. And now multiplying both sides by negative 1, we get that x is equal to negative log base 10 of 2/3 over log base 10 of 2. Minus 1, and that means that x is equal to You can throw this into a calculator. It's going to be a messy value. Go ahead and try it. X is going to be equal to the negative log of 2/3 divided by the log of 2 minus 1 is going to be negative 0.4. That makes sense. Negative 0.415, let's say. Roughly negative 0.415. That's our x-intercept. And so that's around here, right? And again, the parent function, y is equal to 2 to the x, looks something like this. And we have an ry and an rx, so we should expect it to be reflected like so and like so. And so we are going to see it looking something like this. And it's going to trail off. It's going to go through the x-intercept and the y-intercept that we just computed. And then after that, it trails off in the way that exponential functions always do. And this would be, for me, a good enough sketch for this exponential function. If you want your sketch to be a bit more precise, you can always compute specific points on your graph. You can plug in x equal to 1, x equal to 2, x equal to negative 1, negative 2, whichever values you want to have a specific point at on your graph. That'll make your sketch a bit more accurate. But again, for a rough sketch, it would look something like this. So I hope that helps, and thanks for watching.